Hello everyone, and what you just saw there was the Galton board, a device that generates a predictable distribution given the randomness of, in this case, 3,000 individual pegs. Now, the second half and more concrete part of my project was determining what this distribution was. From the first half, we determined that the distribution should be binomial, but we can see that when we compare it to the actual data, this is not the case. The reason why this binomial distribution does not fit our data is because the beats themselves, as you saw, are bouncing all over the place and bouncing off of each other, and the bins aren't actually aligned, in this case, with the pegs at the bottom row. Now, to try to account for this, and still try to get some sort of model to fit this data, what we can do is approximate it as normal. And based on this, using the appropriate statistical test, the p-value comparing this distribution to the data is actually on the order of 10 to the minus 5, which, given that visually, is rather surprising. But the reason for this is similar to before. The pegs on the bottom row aren't actually aligned with the bins. So grouping the bins into pairs and running the same statistical test again, the result actually is a p-value for every single sample, for every single trial, of 0.99 or greater. And what this means is that this data most likely, most definitely, came from that normal distribution. And that there is the crux of this project, the correct use and choice of statistical models and tests, the incorrect use of which can contradict what we clearly see with our eyes, that the Galton board produces a distribution that is indeed normal. Thank you.